Good morning, my dear students. So in this PPT, in this lecture video, I am going to deriving a equation that is a body subjected to a body force, traction force, point load, and also we will discuss about the Gaussian quadratic, that is one point and second point and 2D integral. Okay, that is a numerical integration method. Okay, so here that is what this topic I am going to discuss now. Okay, so this is what where that. Okay, so the body force. Okay, the forces terms here, the body force, the traction force, and this. Okay, and the point load, and also we will discuss about this Gaussian quadratic 1 point and 2 point formula. Okay, what do you mean by these Gaussian quadrature, why we want to use these. Okay, so okay, let us consider. Okay, so first in examination they may ask you derive an expression for the subject to what the body force, traction force, point load. Okay, subject to any of the given element. Okay, so the body subject to a what, body force, traction force, point load, what is the total work potential that particular element, what going to happen, what is the total equation that you need to calculate. So in this equation. Okay, so look at here, consider a body. So this is a body. Okay, so consider the three-dimensional object. Okay, so one is, this is the f of x is nothing but along the x direction, f of y nothing but the force acting along y direction, and f of z nothing but what the forces acting on z direction. Okay, so here the surface force in this body there are three forces will be acting, that is body force, traction force, and point load. Okay, so body force nothing but what, the forces, okay, which will be act entire the body. Okay, so and it is denoted by capital F. Okay, traction force is nothing but what, here that surface force, it is also called as a surface force or traction force. It means what, the force which is applied over the surface of the body. Okay, so that is called as a traction force. And point load nothing but what, a particular point. Okay, so that particular point the force is going to act on the given body or surface, we are going to call as point load. Okay, so these are the what, these are the forces acting this on the body. Okay, so this is volume. Okay, three direction, where and this is fixed to the ground where displacement is going to become zero. Okay, so here, okay, now coming to the first one, let us consider a force, that is a body force. First one, the what, this what, body force. Okay, so here the body force of a vector f is given by the body force act on the particular body. There are three directions, so which is equal to f of is equal to f of x, f of y, f of z. Okay, the forces acting along x direction, the force acting along y direction, and the force acting along z direction. Okay, so because of this force, okay, there will be a work potential takes place. Okay, so work potential due to body force which is given by f is equal to total volume u of t f of into dv. Okay, so where u of t is nothing but what, the displacement in three direction. Okay, so this is what the first equation, you have to remember this. Okay, similarly the traction force. Okay, the traction force nothing but what, here the force which will be act on the surface of the body is called as a traction force. It is also called as a surface force. Okay, the force vector t due to the traction force which is given by along the same three direction. Okay, and it is denoted by capital T is equal to t of x, t of y, t of z. Okay, which is equal to, if you wrote the transpose means like tx, ty, tz. Okay, so here because of this force the work potential of the traction is given by the total entire body. Okay, that is t is equal to u of t is equal to t into ds. This is in one direction. Okay, this is the total direction. Okay, u of t is equal to what, the transpose of u of x, u of y, u of z. Okay, coming to the point load, so the point load should be act on the particular point in the given body surface. Okay, in the three direction, which is given by p is equal to, and it is denoted by capital P. P is equal to px, py, pz. Okay, force point load acting on in the x direction, point load acting in y direction, point load acting in z direction. Okay, the work potential due to concentrated load P, which is given by the work potential that is due to load P is equal to summation of all the point load entire body u of I transpose is equal to P into I. Okay, therefore the total work potential due to all these forces is equal to, have to make it combine those things. Okay, so here the work potential done by the externally, so consider negative one. So total work done potential is equal to what, summation of, this is due to the body force, this is due to the traction force, this is due to the point load. Okay, if you combine all those things, that which gives the total work potential due to the all the three forces, okay, which will act on the particular element. Okay, so this is the equation you have to derive. Okay, the total work potential on the given surface or the body subjected to three forces means you have to derive this equation. Okay, nothing is there in this derivation, only the three forces will be acting in the three different direction. Okay, because of that forces you have to calculate the work potential, combine all those things, you are going to get that final answer, that is work potential. Okay, so this expression is we are going to call as the body force, traction force, surface force, that is point load. Okay, coming to the numerical integration section. Okay, so what do you mean by numerical integration? Okay, so in so already we studied the numerical integration in I think you studied in the mathematics. Okay, so normally numerical integration nothing but once. Okay, the integration normally we generally generally we encounter the finite element method. Okay, so these are the quite complicated and it is not possible to find a closed for the what close for the solution to the problem. Okay, so with the help of, if you want to make the closer one, we are going to use the numerical integration technique. Okay, so exact and exact, if you want to exact evaluation of the integral associated to the element matrices and the loading vector, it is not always what possible, because of the algebraic complexity. All those things will come into picture. Okay, so in many problems, that is what in finite element analysis, okay, we cannot solve the finite element problem. Okay, definite problem we are cannot going to solve accurate. Okay, so because of that reason, we are going to call as this numerical integration. Okay, so the definition says here, it can be defined as the process of obtaining the approximate value of the following equation with the approximate solution here. Okay, so without actually integrating the function, but it is using the value of the f of x, okay, at some point of x which is equal to the space over, okay, x of is equal to x2. Okay, so that is integration of initial to the final. Okay, f of x is equal to dx. Okay, so this is what the numerical integration formula. Okay, so this if you solve one problem, means you will understand this definition of numerical integration. Okay, so next one is Gaussian quadratic one point formula. Okay, so in FEM solution, in FEM problem, okay, so we cannot solve the definite problem. Okay, so in such a cases, we are going to use the Gaussian quadratic one point formula and 2 point formula. Okay, so here let us consider a quadratic quadrature formula. Okay, with a simple sampling point, that is, if you consider n is equal to 1, then we have this formula. Okay, so maximum, so here this is a local coordinate system. Okay, so integration of -1 to +1 f of zeta into d zeta, which is equal to w1 f of zeta. Okay, so where f of z nothing but what, it is a polynomial order. Okay, so which is for the, if you consider the 2D 1D bar element 2n minus 1. Okay, so already we are going to assume n is equal to 1. If you substitute n is equal to 1, we are going to get 1. Okay, f of z is equal to 1. Okay, where w1 zeta are the parameter, okay, along x direction or y direction, whatever that. Okay, so here, since it is only one dimensional problem, okay, so assume the polynomial order is what, f of z is equal to a0 plus a1 zeta. Okay, then the error should be equal to, okay, so error is equal to what, -1 to +1 f of zeta into d zeta, so minus f1 f zeta, which is equal to 0. Okay, so this plus and minus going to what here, so this we already know this this symbol, this f of z is what here. Okay, w1 f of zeta, if you substitute, means you are going to get zeta. Okay, so again error is equal to, substitute this equation, f of z is f of zeta is equal to a0 plus a1 zeta is there, substitute here. Okay, minus of this again w1 as it is, right, is this okay, value which is equal to 0. Okay, so which is equal to here, what is the constant term, we have make it separate, or integrate and constant term kept outside. So a0 is equal to -1 to +1 integration of -1 to +1 d zeta plus a1 integration of -1 to +1 zeta d zeta minus w1 a0 plus a1 zeta, which is equal to q. Just to re-simplify this. Okay, so again the error equal to what, to a0 minus w1 a0 minus w1 a1 zeta, which is equal to 0. Okay, again here you have to simplify this, take the a0 common here both the side, a0 is equal to -2 omega, that is what, w1 minus w1 a1 zeta, which is equal to 0. Okay, but error is 0 only if when this condition should be satisfied. Okay, that is w1 is equal to, so if you take outside, that is which is equal to 2 and zeta is equal to 0. Okay, these two conditions should satisfy. Okay, so thus the 1 point formula which is given by -1 to +1 f of zeta d zeta is equal to this condition, that is w1 f of zeta. Okay, so which is equal to f of 0. Okay, so this is 0 and this is 2. Okay, so like that, so if you solve the one problem, is you are going to understand this what is 1 point formula and 2 point formula. Okay, similarly if you calculate the similar way, okay, one term going to extra here, w1 f of zeta 1 and f of 2 zeta 2. Okay, so here the 1 point Gauss quadratic 2 point formula, which is given by what, this equation. Okay, so -1 + 1 f of zeta t zeta, w1 f of zeta 1 plus f2 f of zeta 2. Okay, so this expression is used for 2 point formula. Okay, so these values are there. Okay, so if you solve one problem on this Gauss quadratic Gaussian quadratic 1 point formula 2 point formula, means you will understand this. Okay, so this is what the 2 point formula 1 point formula, just you have to remember this formula. Okay, so this formula is very important. Okay, so 1 point formula, this formula you have to remember. Okay, so this is while solving the problem, I am going to use this formula directly. Okay, if you solve 2-3 problems on by using 1 point formula 2 point formula, means you can derive this equation, okay, easily. Okay, so coming to the again similarly here this one. Okay, 2 point formula also you have to remember this 2 point formula. Okay, so 2 point formula also this is there. Okay, this you have to remember 2 point formula. Okay, this is most important to solve the problems. Okay, so similarly the Gaussian quadrature for the 2D integral also there, so this is also used for to define definite problem. Okay, so such during some in FEM some problem we cannot solve the definite problem. Okay, such case we are going to use this Gaussian quadrature formula, that is 1 point formula 2 point formula, all those things. Okay, so let us consider what Let's consider the problem of numerical evaluating. So already we derived this numerical integration, okay, double integration, okay. So here two dimensional they are telling. So integration of double integration -1 to +1 -1 to +1 f of zeta into eta, so d zeta into dn, okay. The Gaussian quadrature for the two dimensional integral is we are given what, make it separate one. So I is equal to -1 + 1 -1 + 1 integration of this -1 to +1, okay, f of zeta into eta d zeta d eta, okay. So again you have to write the two times here, okay, wi wj, so along x direction and y direction, okay, f of zeta I eta I, okay. So we know that I is equal to, just to simplify here, if you consider the this is the two dimensional integration, okay. So f of 1, okay, w1 integration of w1 f of zeta 1 eta 1, okay. So here three direction will be there, okay. So here w1 w2 w3 you have to replace here, okay. So you are going to get this equation, okay, that is look at this third element, okay. So this is a w1 is equal to what, I is equal to w1 f of zeta 1 eta 1 plus f2 w2 f of zeta 1 n2 and plus w3 f of zeta 1 eta 3, okay. So that is what here the integration in the two direction, okay. So that similarly w1 w2 w2 you have to write, okay. So these equations we are going to finalize, okay, summation of all those things you are going to get the, for let consider this equation, okay. For consider a rectangular element, for example if you consider a rectangular element, okay, in natural coordinate system, I already told you natural coordinate system means what, the notations, okay, the x and y, the system will be notation inside the element, okay. So this is the 1 2 3 element, okay. So here the at point 1 point here at node number 1 the values are -1 whole divided by square root of root 3 -1 square root of root 3, okay. So already we calculated with the help of, that is a 2-point formula, okay. So here if you substitute I is equal to double integration, okay, so you are going to get this equation w1 is equal to f of zeta 1 eta 1. So similarly second element, second node, third node, fourth node, okay. So where w1 w2 w3 w4 which is equal to 1, if simplify means you are going to get these values, okay. So these values you have to keep here, okay, that is -1 root of square root of 3 -1 by square root of 3, okay. So this is very, no, this is not important 2D integral, but you have to remember the only the final value, the final equation, this equation you have to remember, okay. Suppose in the, while solving the problems I use this, you can you have to remember this formula, okay. So this one if you consider the triangular element means, okay, the Gaussian quadrature for the two dimensional integral is given by, suppose if you consider triangle means you are going to use w1 w2 w3, okay. So each node you are going to use this integration, okay. So this for the rectangular element, so you have to remember this formula while solving the problem, okay. So this is about the Gaussian quadrature for the 1-point formula, 2-point formula, and body force, traction force, and body force, okay. So you have to, this derivation is very important for the point of examination, okay. So I hope you understand this, okay. Thank you.